Let us make and test predictions using the empirical probability models. Okay, so first, predictions. If we're just trying to say, what do we think is going to happen? Well, we're going to take our theoretical probability, like mathematically what should happen, and we're going to multiply by the frequency, how many times something is actually happening. Okay, so let's do an example of this. We are going to throw a fair six-sided die, which has 6 potential sides, right? 1, 2, 3, 4, 5, 6. If I throw this die 30 times, predict how many times I'll throw a 6. Okay, now we just said theoretical probability times the frequency. Okay, the probability of rolling a 6 on a fair six-sided die is 1 out of 6. There are 6 total outcomes. One of them is a 6. So theoretical probability, 1/6. Now let's multiply by the frequency. How many times are we doing this? 30. So if I do this 30 times, realistically, 1 out of every 6 times should be a 6, right? So if I multiply this, we can make 30 into a fraction by putting it over 1. We can reduce numerator to denominator. 6 goes into both of these evenly 5 times. So 5 times 1, 1 times 1, I get a 5. So we can expect 5 times I will roll a 6. Roll, throw, whatever you want to call it. So that's the idea of a prediction. Now, that's if we don't know what's happening, but sometimes we actually do experiments and we keep track of our data, and this is what we then use to call, empirical probability. So it's based on what has actually happened, right? It is based on an existing experiment. So if I would sit at my desk and I would throw a die like 50 times, and I would keep track of every time what number it was, then I could say, okay, based on my experiment, the probability of my next roll being a 4 is, and it's going to be maybe close to the theoretical probability, but probably not exactly. So now with empirical probability, we do the number of times it actually happened over our total tries. Okay, so let's look at some examples. I threw a fair six-sided die 20 times, and I rolled a 5 3 times. Based on this experiment, what is the probability of rolling a 5? Okay, so we have a 5 over the total, right? This is what we're looking at. How many times did I roll a 5? Well, 3 times. So let me change this to roll a 5. Okay, so I rolled a 5 3 times out of 20 total. So this would be my empirical probability, where we know theoretically rolling a 5 on a six-sided die would be a 1 out of 6, right? This is theoretical because there are 6 sides and one of them is a 5. These two fractions are not equivalent because they are based on different things. The bottom one here is based on theoretical, what should happen, but the top is based on data that has actually already happened. Okay, so you kind of have to pay attention to what you're working with. So no, we often will use theoretical to make predictions when we don't have empirical data. All right. Now, one thing I want to talk about is thinking about basketball. Let's say at the very beginning of a basketball season, before anybody has done anything, the probability of making a basket, let's just say a free throw, is 1/2, right? You either make it or you don't. So there are 2 options, 2 tries, and only one of them is a made free throw. So we could say literally every player in the NBA, when they start the season, has a 1/2 probability, right? This is theoretical. But then players play, right? So a basketball player has attempted 72 free throws so far this season, making 65 of them. Based on this data, what is the probability she makes the next free throw? Well, with empirical, so we're based on this data, so this is empirical probability, we want what has happened over our total tries. Okay, well, What has happened? She's made 65 out of 72. That is a very different probability than 1/2, right? So that's the difference between theoretical and empirical. We see a lot of empirical in sports when they talk about free throw percentage or 3-point percentage. In baseball, batting average is an empirical probability, right? So a lot of times in sports, we talk empirical probability based on what has already happened.